My name is Gayatri and my teammates are Charan Reddy and Deepak. Today we are presenting our project titled Student Risk and Performance Analytics using Medline Architecture with end-to-end pipeline. This project focuses on transforming raw educational data into meaningful insights to identify at-risk students and improve learning outcomes. The main thing is business pitch. Today, education systems collect massive amount of data, but most of it is never actually used to help students. Every year, thousands of students drop out from online courses, not because they are incapable, but because no one noticed the warning signs early. What if we could detect struggling students before they fail? What if teachers could take action at the right time instead of reacting too late? Our project answers to this. We built a data driven system that transforms raw student data into early risk detection insights, helping institutes to identify risky students, improve performance, reduce dropout rates. This shifts education from reactive proactive decision making. Our project uses the student demographics and online education data named as OULAD. It includes student demographics, course structures, assessment scores, VLE, where VLE stands for Virtual Learning Environment Activity. Why we chosen this dataset? It contains real world behavior of students, combines performance plus engagement. It is mainly ideal for predicting success and output. Our project is domain is related to education analytics. This is important because present days online learning is increasing, dropout rates are high, institutions need data driven insights. The main technology stack used here is Databricks, PySpark, and Delta tables for reliability and SQL for some querying. This is the dataset we collected. It is an open university learning analytics dataset. It contains 6 to 7 tables where assessments.csv, courses.csv, student assessment, student info, student registration, and student VLE, and VLE.csv. It contains almost 20 lakhs plus records. Remaining will be continued by my teammate.
Hello, I'm Deepak and I will explaining the technical architecture and implementation of our project. Our project follows the Medallion architecture, which is a modern data engineering approach for building scalable data pipelines. It consists of three layers: bronze, raw data; silver, cleaned and transformed data; and gold, business level insights. Each layer plays a key role in transforming data step by step into meaningful insights. In the bronze layer, In the bronze layer, we handle data ingestion. We imported the raw CSV datasets into Databricks. The data includes students' information, courses, details, assignment records, and VLE interaction. At this stage, no transformations were applied, so the original data remains unchanged. We store the data as delta tables for better scalability and reliability. This layer ensures we always have a raw data backup. And the next layer is the silver layer. In the silver layer, we performed the data cleaning and transformation. We removed the null values and duplicates, standardized column formats, joined multiple datasets. For example, students with courses, assignments with performances, VLE data for engagement tracking. This step is important because raw data is not directly usable. This layer covers raw data into structured and usable format. And the next layer is the gold layer. In the gold layer, we created business level insights. We built table for pass rate calculation, dropout analysis, risk categorization, top performing students. These are the optimized for dashboards and reporting. In the goal layer, we focused on generating business level insights from the process data. This layer is designed specially for decision making, reporting, and dashboards. We created multiple aggregated and analytical tables such as pass rate calculations, which calculate the percentage of students who successfully completed courses based on their final assessment scores. Dropout analysis identified students who did not complete the course or stopped engaging with platform. Risk categorization, we classified students into categories like high risk, medium risk, and low risk. And top performing students, identified students with consistency, high scores, and strong engagement. All these insights were created using aggregations, filter, and group operations on the clean silver data. Thank you.
I am Charan Reddy. As Deepak said, we have used Medallion architecture pipeline. After coming to this, we have key insights revealed in that there is a engagement versus dropout risk and course performance patterns and risk distributions. We have created a job pipeline in Databricks. See, this is the education analytics pipeline. These are the bronze tables and these are the silver tables. This is silver enriched table, which is used to create the KPIs, and these are the gold tables. These each table is a each KPI, and we can see final outputs in the KPI tables. These are also known as trends, in which we can observe dropout percentage, pass percentage, and risk distribution. Coming to this, we have analysis to the risk distribution, in which number of students fall into high risk and low risk. After that, the business impact of this data using this analytics is early identification of students at whose they are in the risk through engagement monitoring. The data is driven into improve student success rate, which means high risk students are need to come under low risk for their future education. And there is a future enhancement scope, which is using machine learning we can predict risking score, and we can analyze the real-time data processing autoloader, which is used as azure azure databricks and amazon s3, which is used to autoload the data, and we can set a automated alert system for high risk students. We can use it to create a dashboard integration, and we have created a dashboard using this data in the databricks. This is the student analytics dashboard. In this, we have came here risk distribution, which means how many students are there at high risk and low risk. Coming to this, there are 1.89 lakh students were in the higher risk and 7.88 lakhs in the lower risk, which shows how many students are there at the risk level. And this analysis will be shown dropout rate by module, which means it shows the difficulty level of the module, and we can see how many students are dropped out. Coming to this average score of a module, here there are many modules. We can see that the average score will be shown like this. For coming to AA module, we can see average score is 69. Coming to VBB, we can see 76.24. Like this, we can analyze the data, and at student risk by course, based upon the course, the students are at higher risk, which is AA module, BB module, and these are the remaining modules. We can see how many students are there in the risk. And coming to the pass versus fail distribution, we can see how many students are passed in the distinction, and how many students are passed, and how many students were withdrawn from the course, and how many students were failed. This will identify the percentage and student count with the distinction and remaining results. Coming to engagement versus attempts versus score, we can check how the students are there in the engagement level and their scores. This is the final dashboard. We can see that dropout percentage is 16.2 percentage and risk students are 1.89 lakhs. Finally, we conclude that we have created a successful dashboard in which we can identify the latest trends and we can identify how many students are there in the risk level. We built a complete data pipeline using Medallion architecture. We transformed raw data into business insights and created a dashboard for decision making. In the future, we can make into the machine learning powered risk prediction and real time dashboards and alert system for risk students, and we can bring this into a enterprise level scalability. This is the OULAD education analytics end to end pipeline and the dashboards. Thank you.